Section 5.5 deals with the fundamental theorem of calculus. So the fundamental theorem of calculus says this: let f be continuous on a closed interval from a to b. Then the integral from a to b of f of x dx is equal to the antiderivative evaluated at the upper limit of integration minus the antiderivative evaluated at the lower limit of integration. Again, where f is the antiderivative of little f, that is that the derivative of capital F is equal to little f. So this allows us to find the antiderivative using the formulas, the rules that we knew from section 5.1 and 5.2, and use that to find the area. Now, with the definite integral, you have no plus c. Again, with the definite integral, you won't write plus c. You only write plus c with your indefinite integral. So let's evaluate the following integrals. I want to find the integral from -1 to 2 of 2x plus 3 dx. So let's just go ahead and integrate 2x plus 3 first, using the rules we know from section 5.1. Well, I know that 2 is a constant multiplier, multiplies along. This is x to the first power, which means my n is equal to 1. So that's going to be times 1 over 2 x squared plus 3 is just a constant. It's my k. Therefore, this is going to be 3 times x. Now, typically we wrote plus c, but here we do something different because we're having to look at the definite integral. So instead of the plus c, we write this line here. And then we write the lower limit of integration on that line and the upper limit of integration on that line. So what we're saying is we are going to evaluate this antiderivative that we just got at these limits of integration. So if I clean this up, this is just going to be x squared plus 3x. And again, we're going to evaluate it from the limits of integration of -1 to 2. So the fundamental theorem of calculus says, hey, you want to find the definite integral? Well, you have to evaluate the antiderivative at the upper limit of integration. So in our case, it's going to be 2 squared plus 3 times 2. And we take that and we subtract off by plug in the lower limit of integration. So in this case, it's -1 squared plus 3 times -1. So we do this in a calculator. So here we're going to end up with parentheses 2 squared plus 3 times 2, close that parentheses, minus, open another parentheses, then parentheses for -1 squared plus 3 times -1, and we get 12. So the integral from -1 to 2 of 2x plus 3 dx is equal to 12. What about number 2? The integral from 1 to 2 of 1 over x dx. So first, let's just use the rules we know to integrate 1 over x dx. Well, the integral of 1 over x dx we know is equal to the natural log of the absolute value of x. And again, typically we write plus c, but because this is a definite integral, we write our bar, place our lower limit of integration there, and our upper limit of integration there. So then this becomes the natural log of the absolute value of 2, plug in the upper limit of integration, minus the natural log of the absolute value of 1, plug in that lower limit of integration. Well, the natural log of 1 we know is equal to 0, so we can just cancel that term. And 2 we know is a positive number, so this is just going to equal the natural log of 2, which if we grab a calculator, the natural log of 2 is going to be approximately 0.693. So this is going to be approximately 0.693. Now sometimes my math lab wants the exact answer, and sometimes it wants a rounded approximate answer. So if they're asking you to do an exact answer, make sure you give the exact. If they want the decimal answer, make sure you round to whatever place they say. Okay, let's look at example 3. More of the same. I want to evaluate the integral, and I'm given the definite integral from -8 to -1 of 1 minus the cubed root of x dx. Now, just like anything else, anytime I see a cube root, I've got to change this into a power. So this is the same as the integral from -8 to -1 of 1 minus x to the 1/3 dx. So if we evaluate this integral, we know that the integral of 1, well, I know that that's just a constant, so that's going to be 1 times x, minus here, my n is equal to 1/3, so this is going to be 1 over, well, 1/3 plus 1 is 4/3, times x raised to the 4/3, and again, this gets evaluated from -8 to -1. And if I clean this up, this is the same as x minus, well, 1 over 4/3 is just going to be 3/4 x to the 4/3, evaluated from -8 to -1. So the fundamental theorem of calculus says, all right, start by plugging in your upper limit of integration. So this is going to be -1 minus 3/4 times -1 to the 4/3. And subtract off, plug in your lower limit of integration. So now -8 minus 3/4 times -8 to the 4/3. And if we do this on a calculator, we have parentheses -1 minus 3/4 times -1 to the 4/3. And then we subtract that from -8 minus 3/4 times -8 to the 4/3. And we get 18.25. So this is going to equal 18.25. All right, let's look at number 4. Well, number 4 says the integral from 4 to 1 of 6x minus 5 dx. So, again, just integrate 6x minus 5. So we're looking at 6, a constant multiple, multiplies along. This is my n equal 1, so that's going to be 1/2 x squared. Here, my constant is 5, so minus 5 times x, and this gets evaluated from 4 to 1. So let's clean it up before we evaluate. Well, half of 6 is 3, so we're looking at 3x squared minus 5x evaluated from 4 to 1. So plug in your upper limit of integration. So you're looking at 3 times 1 squared minus 5 times 1, and that gets subtracted from, plug in your lower limit of integration. So 3 times 4 squared minus 5 times 4. And again, we're just going to complete this on a calculator. So on a calculator, we would say 3 times 1 squared minus 5 times 1 minus 3 times 4 squared minus 5 times 4. And we'd end up with -30. So the definite integral from 4 to 1 of 6x minus 5 is -30. Let's do example 5. Example 5 is the integral from 0 to 2 of 4e to the x dx. Again, I know how to integrate 4e to the x dx. 4 is a constant multiplier, it multiplies along. So we're looking at 4, and then the integral of e to the x is e to the x, and it gets evaluated from 0 to 2. So plugging in the upper limit of integration, we're looking at 4e squared minus plugging in that lower limit of integration, and that's 4e to the 0. So then this becomes, well, 4e squared is just 4e squared, and 4e to the 0, remember e to the 0 is just 1, so that's 4. So again, sometimes the book wants the exact answer, so sometimes it's going to want you to put 4e squared minus 4. and sometimes it's going to want that approximate answer. So the approximate answer here would be 4 times e raised to the second power minus 4, and we're looking at 25.556. So this is going to be approximately 25.556. Number 6 looks horrendous. The integral from 3 to 3 of 5x squared minus 6x plus 3 minus the cubed root of x plus 1 over x squared dx. It's a little tricky. It's that property we learned in section 5.4. When your upper and lower limits of integration match, remember the width of our rectangle is 0, so the integral from a to a of f of x dx is equal to 0. So in this case, the integral from 3 to 3 of anything is equal to 0. So number 6 is equal to 0.